we have about 4 problems to do, but they take some time because they are word problems. Don't you love it?
No.
I know. When I was your age, 1,000 years ago, I used to skip the word problems because I just didn't want to read them. I'm like, what? There's words in math? Skip. We're not going to be like me. We're going to be better than me. All right, so I've got 4 different types. Here we go. Number 1. Now, for these problems, I want you to read them through, set up an equation, and then solve that equation, and then look to see what the question's asking, and then answer it. So we have 2 cars leave, very classic problem. 2 cars leave at the same time. Cars leave at the same time, and what they are doing is they are going in opposite directions at the same time. We'll continue that sentence in the opposite direction. Okay, I'm going to say that they're on the freeway because they're going pretty fast. They're not in the neighborhood. Do you ever yell at people who drive down the street fast? I do. Mm-hmm. I do. Now the guy just revs his engine every time he goes by my house, so maybe I shouldn't have. Okay, 1 car averages 60 miles per hour, and the other one 70 miles per hour. So yeah, maybe they're out on the highway somewhere. And the other 70 miles per hour. Okay. We're going to find the time it takes. So how long? It's a lot of words, isn't it? It's the most wordy out of the word problems we're doing today. How long will it take? How long will it take them to be 455 miles apart? To be 455 miles apart. Okay, I'll let you write that down if you are. So we've got 2 cars leaving at the same time in opposite directions. 1 car averages 60 miles per hour, and the other 70 miles per hour. How long will it take them to be 455 miles per hour? Okay, for this problem, you need to know a formula. You need to know one. I think you have done this before, but if you know anything about driving in the car, distance equals your rate times time. So, for example, if you're going 50 miles per hour for 2 hours, you will go 100 miles. Okay? That's a formula that maybe you don't know, but you do now. So let's go ahead and write it like this. So here's the first car. Let's say it's going this way, and it's averaging 60 miles per hour. And then the other car is averaging 70, so he's going to get a little further. He's going faster. And the entire distance here is 455 miles. Okay. So distance is equal to your rate times time, and we don't know what t is in this question. Okay? But if this is the first driver and he's going 60 miles per hour, then I know that his distance would be 60 times t. Does that make sense? Yeah. Just for that guy. 60 miles per hour times however hours he's driving. And then the other guy, they're driving the same amount of time, but he has a different speed, and he was 70 times t. Okay, so then together, we're going to add up their distances. This guy's distance, which is 60t, plus the other one's distance, which was 70t, and that equals a total of 455 miles. And there's the equation. Getting there is the hardest part, though, setting it up, because I know that you guys are good at solving this, right? So 60t plus 70t is 130t equals 455. Divide both sides by 130. So the time that it's going to take is, get your calculator out, 3.5 hours. Oh, and that's the other thing I wanted to tell you. If your problem has words in it, your answer should have some kind of a word in it. Or if it's a money problem, it'll have like a dollar symbol. Okay? So 3.5 what? 3.5 days, 3.5 years, 3.5 hours. Pretty good? Can you do one like that? I think you have one in the homework like that. All right, number 2. This one's easier. There's this thing in Belgium. Has anyone ever been to Belgium? You have?
No, I'm asking.
Yes? I was going to say, no, you haven't. Yes?
Is it okay if we abbreviate?
Sure. I love abbreviations.
Testing.
Why is abbreviation such a long word? Okay, number 2. Here we go. Anyways, there's this thing in Brussels, Belgium, and it's a rectangular thing, and it's called a flower carpet, they call it. It's like all flowers. Have you ever been to Bouchard Gardens? No? In Victoria, Canada?
Oh, I've been
It's all
there.
flowers.
I
Oh,
haven't
so
been there.
pretty. Okay, anyways, so there's a whole bunch of these little, flowers here. Anyways, they're better than that. Okay, it's really good, huh? And so they tell us that one side is 3 times longer than the other side of this thing. So that's the proportion it is. So this is x, and the other side is 3 times as long, so 3x. And they tell us that the entire perimeter of this flower garden is 200 meters. Let's see, we're in a different country, so we're in meters. All right, so it's 200 meters. And they want us to find the dimensions. They want us to find out how long and how wide this flower carpet is. Find the dimensions. You see that S right there? That means there's going to be 2 numbers that we're trying to find. The dimensions. Okay. So do you know perimeter? Yeah? Perimeter is to take all the sides and add them up. And so if this side over here is 3x, then this side would be 3x. And if this side over here is x, that one would be x. So let's go ahead and set up our equation. We have to add up all 4 sides and set it equal to 200. And you can do this, right? What is that, 8x? 3, 6, 7, 8. 8x equals 200. Okay, I don't need you to write 3x plus 3x plus x plus x. So you can do that part, do a little step ahead in your head. And then divide by 8. So x equals 25. Okay, now a lot of people will stop there and be like, cool, next question. No, you're right. We need to find the dimensions, okay? And we need to put a unit on this too. So this is 25 going this way. The other side is 3 times x. So how long is the other side? 75. So this dimension of this flower carpet is 25 meters by 75 meters. Good. That's a good one. Does that feel very geometry-ish to you? Yeah, it is. The next one is 2. Any questions on that one? Do you want to know what a flower carpet is? It's on page 61 in your book. All right, number 3. Here comes another geometry problem. It says here that the complement, it's spelled differently. I think it's with an E. It's not like, oh, you look pretty today. It's not that kind of complement. The complement of an angle, did I go too fast? I can slow down. I can't. I have 1 speed. It's fast. All right, the complement of an angle is 10 degrees more than 3 times, there's a lot of words for this one too. The complement of an angle is 10 degrees more than 3 times the other angle. Okay. We're going to need to figure out what complement means and all that stuff. So the complement of angle is 10 degrees more than 3 times the other angle. We are going to find the angle measures. Find the angle measures. How many degrees does a circle have? 360. I hate it when people say, oh, I've changed my life around. I made a total 360. You'd be right back where you were, right? Like they have this Weight Watchers plan. It's Weight Watchers 360. I'm like, okay, so you're back to being,
Okay.
Yeah.
Okay, so
Yes. Took the history of math. All right, so let's do this. Our first angle, let's go with the non-complicated one, we will call x, okay? That's the other angle. Now, the second angle is, it says here, 10 more than 3 times the other. How do we represent that? Anybody want to take a guess? 10 more, than 3 times the other. So we can write that as 3x plus 10. Remember we did that translating a few days ago? That was kind of helping us get ready for this. All right, so now we need to know one more thing. The complement. The complement of two angles and the other one, which is supplement, right? Complement is when the two angles add up to 90 degrees. So like 60 and 30, 45 and 45. Those are complements. Supplement is when they add up to 180. Do you have a fun way to memorize that, or you just know it? So in my last class, I said, no, you just know it. And then someone said, no, I have a little way. C comes before S, 90 is before 180, alphabetically, numerically. Someone else said, ooh, C reminds her of corner, and a corner is like a 90 degrees. I know, I like that. I've never heard that one. That was cute. I used to say, when I taught geometry 1,000 years ago, I used to say 180 is like this, and you're like, yo, what's up? And everyone's like, no, please don't do that. So I stopped. So I still do it every year. Yeah.
I have one.
20 years ago. Yeah. You do? What is it?
Well, so if you actually...
All right, so let's set up our equation. So since they are complements, they're complementary to each other, we would set up x plus 3x plus 10. So that's the first angle is x, the second one is 3x plus 10, and they should equal together 90 degrees. Okay, and then you solve. So we get 4x, and I'm going to subtract 10 to the other side. So x would equal 20 degrees. 20 degrees. And then the other one is going to be, now you can think of it two ways. One, they're complementary, so they have to add up to 90. So the other one would be 70. Or you can think about it as, okay, so it's going to be 3 times this one and then plus 10, so that's also 70. All right, last kind, number 4. We're doing okay on time. Good. Number 4. All right, we're going to do what's called a consecutive integers problem, and I have 2. Don't you hate it when they're like, I've only assigned 3 problems, but then they have like A, B, C, D. Consecutive integers. First of all, consecutive, of course, means right in a row, okay? And integers are no decimals, no fractions. So consecutive integers, like 1, 2, 3, or 10, 11, 12, or 100, 101, 102, stuff like that. All right, so we got 2 of these. Here we go. It says here that the sum of 3 consecutive integers, is 33. We're going to find the numbers. Now, find the numbers. If I put this on a quiz or test, this is going to be a 2-part problem. I'm going to A, say to set up your equation, and B, go ahead and tell me the 3 consecutive numbers, okay? Because I know some of you guys can do this in your head. I had someone in my last class, a talkative kid. He said it. Yeah, you got it. Some people got it already. But I want you to set up an equation, because they do get harder, okay? So here we go. This is what you're going to do. 3 consecutive numbers. So I have one number plus another number plus another number equals 33. Okay? And here's how I always set these up. My first number, I call x. Okay? The next one after that, like if I'm going from 5 to 6, 6 to 7, it's x plus 1. That's what the second number is. And then the third number is x plus 2. It's 2 away from that first original x. And that's it. That's how they're set up every time for these consecutive integer problems. X plus 1, x plus 2, and then we solve. So how many x's do you have? 3? Wow, that's a lot of x's. Get it. All right, 3x plus 3 equals 33. And then maybe so you can solve that in your head. Subtract 3, divide by 3. If you need to show the work and write it out, that's fine. So x equals 10. Okay. I do need to find the numbers, plural. So I would have 10, 11, and 12. You got those? Yeah. Add those up. Do they add up to 33? Yep, they sure do. Okay. Now this one's going to have a little twist to it. Little twist. We are going to have the sum of 3 consecutive even integers. Okay, I'm going to teach you how to do these. 3 consecutive even integers, and their sum is 72. We're going to set up an equation, and then we're going to solve that equation. Equation, and then B, we're going to list our 3 numbers that we find. Okay, now, no matter what, even or odd, these are done the exact same way, okay? Even numbers are every 2 numbers, right? Odd numbers, every 2 numbers, not every 3 numbers because it's odd. It's still every 2 numbers. So to set up this problem, you're going to still have, your 1, 2, 3 consecutive, or even numbers, 3 numbers. You're going to add them up. They're going to equal 72. But here's how we write them. Our first number is still x. Just keep it simple. Keep it x every time. Now, whether this is even or odd, where's our next even number? X plus 2. Okay? Even if that was an odd, like 3. How do you get from 3 to 5? You add 2. How do you get from 5 to 7? You add another 2. So then that would be x plus 4. So consecutive numbers are x, x plus 1, x plus 2. Even or odd numbers are x, x plus 2, x plus 4. And now let's solve it. We've got 3x plus 6 equals 72. Subtract 6. 3x equals 66. So x is 22. So then to answer their question, go back and find out what they're asking for. We want 22, 24, 26. And then you can add them all up, find out if they're 72 and they are. Yay! Okay, let's talk about what's going to be on your quiz now. You have your first quiz tomorrow. Don't be scared. A couple of things. Thing number 1, quizzes are always 25 points. I know it's a lot. Sounds like a lot. The other thing is, if you don't do so hot on a quiz, remember, you can always make up those points on the next test. And that's good for 1 quiz in a chapter. So here's what you need to know for tomorrow's quiz. You need to know how to plot points on a number line. Okay? Plot points on a number line. I might give you a decimal or a radical or a fraction. Make sure you know where they land on a number line. You are also going to do which one's bigger or smaller. Okay? With harder problems, not like 5 and 7, but a little harder. You need to know the number names. The number names. So you need to know what a real number is, what a whole number. Remember those? We did those on the first day of school. Number names. You need to know your properties. Not all the properties that are in the book, but the ones that I gave you in the notes a few days ago, because there were quite a few in the book, and we narrowed them down to the really important ones, like associative, commutative, distributive, stuff like that. And then you're going to need to do some stuff. You're going to need to know how to evaluate, which is just a fancy way to say plug it in. So you'll have an algebraic expression, and I'll say let x equal 5, and you plug it in and you get a number. You're also going to need to simplify. Okay, simplify is when you combine like terms. So you'll have to do some of those. Remember, like terms are the same variable and the same exponent. You have all this written down in your notes somewhere, hopefully. You're also going to have to solve a few equations. I think there might be 3, maybe 4. Solve equations, show your work. Okay, they're not going to be too tricky. You will have just one word problem. Just one. Something from what we did today or practice in the book. Word problem. And then you're also going to have to, last thing, translate. Translate an English sentence into mathematical, like twice x plus 5 or something. So 2x plus 5. Okay, something like that. And that's it.